Have you ever really stopped to think about the device you're watching this on? At its very core, it's a machine built on absolute certainty. It's a world of on and off, yes and no, one and zero. But what if we could build a computer that doesn't just tolerate uncertainty, but actually thrives on it? A machine that runs on the strange, mind-bending rules of the quantum realm. Today, we're going to explore how this totally new kind of machine could be the key to unlocking the next and maybe the final stage of artificial intelligence.
So let's start with a really simple but huge question. Every single piece of tech we own, right? From our smartphones to the biggest supercomputers on the planet, they're all built on one simple idea. A switch is either on or it's off. A 1 or a 0. That's it. It's the bedrock of everything digital. But what if that wasn't the only way?
What if a single piece of information could be on and off all at the same time? Now, that sounds like a riddle, I know, but it's not. It's the fundamental difference between the computers we have today and the quantum computers of tomorrow. And it turns out, embracing this weird, beautiful ambiguity is the secret to unleashing a whole new universe of computing power.
Okay, so to really get where we're going, we first have to get our feet on the ground with where we are right now. So let's do a quick breakdown of the building blocks of our current world, classical bits and the kind of AI they power.
Every single thing on your computer, every word in a document, every pixel on the screen, every note of music, it's all just a super long string of these classical bits. Think of it as billions and billions of tiny little light switches, and each one is stuck in a definite state, either on or off. Now this system works great, it's amazing, but it has one big limitation. To figure out a problem with lots of possibilities, it has to check them one by one by one.
And the AI that's built on these bits? Well, we call it narrow AI. And honestly, it's everywhere. The AI that can beat a grandmaster at chess or instantly translate a sentence or figure out exactly what movie you want to watch next, it's a genius. But, and this is the key, it's a genius in its own little box. It's a specialist. It's incredibly powerful at that one thing, but it can't take what it learned and apply it to something new. It has zero common sense.
All right, now let's meet the star of the show, the qubit, or the quantum bit. The best way to think about it is this. A classical bit is like that light switch. It's either on or it's off. Simple. A qubit, on the other hand, is like a spinning coin. While that coin is spinning in the air, is it heads or tails? Well, it's neither. It's kind of both. It's a cloud of probabilities. It's only when we measure it, when we slap our hand down on the coin, that it collapses and is forced to choose heads or tails, 0 or 1.
So this whole idea of being more than one thing at once, it's not just a cool party trick. It's the source of two absolutely incredible quantum superpowers that give these machines their almost mythical power.
Superpower number 1 is called superposition. It's exactly what we were just talking about. By holding on to both 0 and 1 at the same time, even a small number of qubits can explore a ridiculously huge number of possibilities all at once. Think about it like a maze. A classical computer has to try one path, hit a dead end, go back, and try another. A quantum computer, because of superposition, can kind of explore every single path simultaneously. That's the secret to its massive parallel processing.
Okay, if you thought superposition was weird, hold on. Entanglement is where things get really strange. Imagine you have two of those spinning coins, but they are magically linked. The instant you slap your hand on one and see that it's heads, you know instantly that the other coin, even if it's on the other side of the galaxy, has to be tails. That's entanglement. These qubits share a deep, mysterious connection that's faster than the speed of light.
And hey, don't just take my word for how bizarre this is. The idea was so weird and counterintuitive that it famously bugged Albert Einstein himself. He's the one who gave it its classic nickname, spooky action at a distance. And it just goes to show how different the rules are down at the quantum level.
So, with these mind-bending superpowers, you're probably asking the obvious question. Why don't we all have quantum laptops? Well, the simple answer is that grabbing hold of this quantum power means we have to solve some of the biggest, most insane engineering challenges humanity has ever taken on.
See, here's the biggest problem. The quantum world is, well, it's shy. Superposition and entanglement are unbelievably delicate states. The tiniest disturbance from the outside world, a little vibration, a stray bit of heat, even a random magnetic field, can make the qubit forget its quantum magic and collapse back into just a boring, useless classical bit.
And this shows you just how extreme the solutions have to be.
To shield these delicate qubits, the leading quantum computers have to be kept inside these massive, complex refrigerators that cool them down to just a tiny fraction of a degree above absolute zero. We're talking colder than the vacuum of deep space.
This process of losing quantumness has a name. It's called decoherence, and it is the arch nemesis of every single person working in this field. Honestly, the whole game of building a quantum computer is a constant war against decoherence. It's a race to finish your calculation before the outside world crashes the party and ruins everything.
Okay, so we've got these ridiculously powerful but also ridiculously fragile machines. So why are we going through all this trouble? What's the ultimate prize that makes this whole thing worth it? Well, for a lot of people, the answer is the holy grail of AI, creating a true human-like intelligence.
We already talked about narrow AI, the specialist. Well, its potential successor is artificial general intelligence, or AGI. An AGI wouldn't just be a master of one thing, it would be a master of learning itself. It could learn to play chess, then use what it learned about strategy to help it learn to cook a new recipe, and then write a poem about the experience. It would have common sense, creativity, and the ability to apply its knowledge to completely new fields.
So how does quantum computing actually get us there? How does it bridge that massive gap? Well, let's connect the dots. The massive parallel processing you get from superposition, that could let an AI sift through messy, complex data in a way that's just impossible for today's computers. And entanglement, that could be the key to helping it model all the subtle, interconnected relationships that form the very basis of our common sense. And finally, being able to explore that huge space of possibilities could be the secret ingredient for true, unpredictable creativity.
Look, putting quantum computing and AGI together isn't just another tech upgrade. This would be a fundamental turning point for humanity. And like any tool this powerful, it brings with it both incredible, almost unimaginable promise, and really significant peril.
And don't think this is all just far-off science fiction. We are already on the path. Right now, we're in what's called the NISQ era, which stands for Noisy Intermediate Scale Quantum. Basically, we're working with imperfect machines. But the roadmaps from all the big players are projecting that by the end of this decade, we could have the first truly useful fault-tolerant systems. The pace is picking up fast.
The promise here is just breathtaking. We're talking about simulating new molecules to cure diseases, designing materials from scratch that could help solve climate change, maybe even unlocking the deepest secrets of the universe. But the other side of that sword is just as sharp. A powerful quantum computer could shatter the encryption that protects our banks, our governments, our entire digital life. And the control problem, the challenge of making sure a superintelligence's goals stay aligned with our own, is maybe the most serious question we will ever have to answer.
So, what it all boils down to is this. We are right on the edge of creating a new kind of intelligence, one that runs on physical laws that defy our common sense. It won't just think faster than us, it's going to think differently from us, in ways we might not even be able to comprehend. And that leaves us with the biggest question of all. As we build these new minds that think in a completely alien way, are we actually ready for the answers they're going to find?
Have you ever really stopped to think about the device